Hello, this is the Tepid Coder. Today I want to talk about initializer lists and how to use them, what they do, what they're for. So the way I want to do that is by showing my vector class right now. In my vector, the way I'm adding elements, I'm saying push back. I'm just adding 1,000 elements. Anyway, there is a way where you can make it so you can initialize a class type like this and give it a bunch of values, like 0, 1, 2, right? Something like that. And I think I'm going to show that real quick. So test 0, 1 I'll say for that one. Void. Okay, let's paste that old code in here. Maybe first I'll also show that you can't do it the way it is now. So okay, there we go. So let's actually try and compile this real quick to see what it shows. So I'm going to do g++ test.cp. I also need vector.cp, and the output is going to test. So 38 cannot convert this from brace enclosed initializer list to vector of unsigned character. So it doesn't know how to take those initial values. But there's a way we can make it take those initial values. I'm going to show how to do that. So what we're going to do is we're going to go into our vector header. Inside of here, we're going to need to include something called initializer list. Okay, I'll copy that because I keep typing that. Okay, and then down here where my constructor is, I'm going to add a new constructor that takes an initializer list. So vector initializer list, it comes from standard library. It has some type, which means I also need to put type name in front of it, because it's like a template type. And I'm going to say initialize, initializer. This is plural, initializers. Okay, I'm going to copy this. I'm going to stick that in the vector.cp file. Put it right here. You need to say it's a template. Type name is t. And it comes from the vector. Type t class. Boom. Okay. And then we have to actually put the elements inside of the vector. So what you can do here is you can iterate through this using a for loop with the range operator. So just like when I'm iterating through a vector and I do like for const auto, value colon something, I can do the same thing here for the initializers. Right? That'll work, just like a vector. So that's super easy. So I'm just going to say push back, which is a method from this class, value that I received. Okay, now let's pay attention to this. The only type of template class we can make with this vector currently is an unsigned 8-bit integer vector. So I'm going to use that same type. Okay, so my test application, let's take a look at that. So I have 0, 1, and 2 is what it starts with. Maybe we'll add some stuff to it. Oops, I want vec.pushback. Let's add a 7 at the end. I'm going to do for const auto. We'll iterate through my vector here. I'll say value comes from vec. Okay, and we're going to say standard cout static cast, make it an integer value. I'm going to say end line. Come on. And was I using standard out here? No, I was using fprintf. So let's actually include that now. IO stream. That should work. Okay, let's try and compile and run that again. So I'm going to clear that. We're going to compile it. I'm going to run it, and it works. And you can see it's getting called 4 times here. That's because I'm pushing back inside the initializer list. For every single element I pass, the 0, 1, 2, 3 elements, 1, 2, 3, right here, it's calling it for each of those. And it's also calling it for this. So what I could do in the initializer list is actually be a bit smarter, and I could make it so that I allocate as many spaces, elements in the vector as I need to fit all of these. And I could do the nearest power of 2 that is greater than the number of elements that I passed. So maybe I'll do that real quick. There's actually a new thing in pretty modern C++, I think it's 20 or 23, I think it's Web 20, where you can use this header that lets you get the, what is it called, bit length or something like that? I'll look it up real quick, like bit length or something at bits. I don't know. I'll check real quick. So if I go over to, just like that, C++, nearest power 2 greater than. Yeah, C++ 20 does this, and it comes from, where is it? Come on. Here, it's bit ceiling. Comes from bit. Okay. It's just called bit. And this gives me standard bit ceil, which should find the first power of 2 that is not less than the value that you pass. So the first one is greater than or equal to it. Okay. What you could also do here is basically just use, let's say, ceiling of log, right? It's going to be log n over log of 2. That should also give me the same number, but this is a lot slower. The thing I could do is keep bit shifting, starting at 1 until I find a number that's equal to or greater than the number. Either way, the function already exists, so I'm just going to use this. And because I'm including it in this vector header, it's automatically going to be included in vector.cp because I'm including this vector header here. Okay, so now I have standard bit ceiling I can use. So what I want to do is look at my allocator function in here. Where am I allocating? So if there's no capacity, I'm going to alloc right here. Okay. So let's just steal that real quick. I'm going to dump it right here. I don't need that check, because I know that the data is invalid already. Okay. Alright, so we're going to allocate as much space as we need. So the question now is, does standard initializer list have like a size? So standard initializer list of type T. Let's take a look at that definition here. If I pull that over, what members does it have? We got data, we got begin, end, size. Here it is, number of elements. Cool. That's exactly what I needed. Okay. So we're going to do that. We're going to say the amount I'm allocating is going to be initializers dot size. So I can fit that many elements. However, I can do better than that, right? I want to make it so there's always a power of 2. So I'm going to say size t. Let's see, elements to allocate equals, it's going to be standard bit ceil of this number. Let's find the nearest power of 2 that is greater than or equal to the number of initializers. So if I pass 1, it's just going to be 1. If I pass 2, it's going to be 2. If I pass 3, it's going to give me 4. If I pass 5, it's going to give me 8. See what I'm saying? It's going to be the next highest power of 2. Okay, and let's actually use that now. Okay. Let's try that. We'll try rebuilding everything. So let's clear it. Let's build it. Bit ceiling is not a member of standard. It should be. So let's try this. I'm going to do standard equals C++20. Okay, now we have an error. So returning a value from the constructor. Right, I shouldn't have done that. What I should do here is, if I can't allocate, is I should be throwing throw standard runtime error, let's say. Error unable to allocate enough memory to hold the elements specified in the initializer list. I'm wondering about the error there. It's obviously an exception. Someone's also probably going to catch it and do something like, C error perhaps, and they'll say something like exception, right? Blah. In fact, I'll even take that. I'll be that someone that does that. Let's go to my test.cp file. Let's actually catch it now. I'm going to try. Let's take the whole thing in try catch block. Standard exception. Catch it by reference. And then I'll be that guy I was talking about. Okay. In the quotes here. Okay, then I'm going to say e.what the exception was. Okay, and then standard inline. Okay. Sounds good. I'll actually return 0 here as well. Okay. I'm missing something. There's something I forgot to do. But I think the compiler will tell me. Let's see. So, yeah, I didn't include standard exception. That's what it was. Include. Jeez, I cannot type on this thing. I couldn't type anyway. What am I saying? Okay. Standard except. Okay. Now it should probably work. Okay. And yeah, it does. Now you can see right from the rep we're starting with capacity, let's see, 1, 2, 4, 4. That's interesting. I actually expected to start with the higher number there. Capacity being only 1 here is a bit strange. Oh, it's because I never actually updated the... Hold on a second. What did I say the capacity was? I said it's a 1. Oops. Elements to allocate. That's the issue with copying code and pasting it, trying to save time. For me, at least, I end up wasting more time than I would have saved if I just typed it out from scratch, right? That's probably just me, though. Okay, here we go. So it starts at 4 and it stays at 4. Because it never needs to use any more than that. I'll add another element, though. So let's go back to test.cp. In this case, let's say we start out using all 4 of them, and then we add that 7. So it's going to force it up to 8. So 4, 4, 4, 4 for the initializer list, and then 8. So that's cool. I only do 1 allocation now. And then when I start adding stuff after the initializer list, it adds a new element. But if I had only put 2 in there, I wouldn't have to reallocate when I push back afterwards for the next 2. So either way, that's kind of cool. The other things I can do to make this class a bit better is instead of using malloc internally and realloc, I could just use new, and I'd actually do this actually, new with brackets, because it's multiple elements, then delete with brackets when I'm done with it. And every time I allocate a new node, I would have to delete it, right? And then I'd have to make a new one. Or what I have to do is I'd have to make sure the memory is aligned in a proper way, and then I'd have to basically instantiate each object in the memory I create with this. And that would be the better way to do it, because I can always call a destructor at some address, right? That's not an issue. Maybe I'll show it in a different video. But for now, I think I'm going to leave it at that. Let's space the code over a little bit, make it pretty. And okay, yeah. Anyway, if you guys got something useful from this, if you have any comments, criticisms, feedback, whatever, please post those. And if you want more content like this, please consider subscribing and liking the video. I will catch you guys later. Have a good one.